So, good morning, all. Today we are going to have a lecture which is on utility. Last time, what we had done is it was on preference, and in that lecture, largely we discussed about the reflexive, complete, transitive, and continuous assumptions. And along with that, transitivity and other, along with that, there are other properties of rational choices were being discussed. Okay, and in this lecture, largely we are using that mechanism to understand this different concept, which is called the utility. So earlier, what we had seen is a preference, how we form preference, and how that is different to that of a choice, etc. So we will discuss choice later because choice is in fact a specific issue rather than a preference. Preference is a larger or what you call the bundle of likes of an individual or a collective. So in that sense, again, that is also leading to a certain question that what makes a people to have this preference. So economics, we used to have an opinion or say that it is because of the utility. Okay, and therefore we need to characterize utility and other aspects as because it is very important as far as the conceptualization as well as the theorization of this particular problem is concerned. So, in with this thing, let me come to the lecture. Um, so, given the reflexive, complete, transitive, and continuous assumption, it is possible to show that people are able to rank in order all possible situation from least desirable to the most. So, this is what is actually the most important understanding in an ordinal preference pattern. That means when I say that I prefer X, I say that I prefer X because even if Y or Z is available, but my preference is having more weight towards X. So that is what we try to say. Given that a Y and a Z is available in the set, if there is no Y and a Z in the set, then this is not actually a comparable point. Then you say that this is called a discrete choice. So I'll come to that nitty-gritty problem, the problems and the nitty-gritties of the same in different lectures. Okay, so this is what is normally given because the most important thing is that you have to have at least two uh, basically choice element in your set because otherwise you can't simply say that which one is picked and what is actually the basis of picking of that particular element from that particular set. This is what is the important thing. That is why at least we talk about a two-dimensional vector space. So in that you can say that clearly you can indicate that there is an x exists as well as a y exists. Simultaneously, either you go for an x or y or a combination of both. So in that sense, this is very important. At least you need to have a two element in that set. So if then and then only you can say that the ranking makes some sense. So economists call this is as a ranking, and that ranking in that sense we say that if there is a higher ranking and a lower ranking, that comes with the characteristics which is called the utility. So that is, in other words, if A is preferred to B, then utility assigned to A exceeds the utility assigned to B. This is what is you are trying to make. So if I prefer A, if and only if A is having some value which is greater or better or comparably as good as B, then only you say that A is being preferred. If you say preferred, then you are strictly saying that there is a clear inequality. That is, you say that A is strictly better than B. So this is what is you say, or mathematically or in a logical sense, we notate it in the form that U is A, U of A, which is greater than U of B. That is, utility derived from A is greater than utility derived from B. In mathematics we use this greater than symbol, but in set theory what you do is a slightly different notation. You say that it is as good as, or it is better but not as equal as B. So in that sense what I'm trying to say that this is two different commodity. So this distinction is very important, because when I say apple, a bunch of apple is available to me. Then at the same time, if I say that I am picking up an apple, all the apples are actually looks like alike, but it is distinct. Each apple is distinct in that sense. So all are apples by the identification of the, or the broader identification in the form of logic. So in the set theory, you might have actually come across a setting that, you know, if there are so many apples, you would say that apple. So one apple represents all the apples which is available to you in that sense. So that itself is trying to homogenize certain characteristics of apple, but doesn't mean that all the apples are same. Okay, so it may be having all the apples are distinct elements, but at the same time you say that can be represented as apple. So that is why that reflexive axiom, which we keep telling that that is very important, though it is seems to be very basic or trivial. So I'll come to this portions when we discuss theory, and we will see that the difference is in fact remarkably changes if we slightly varies in any of this component. So in this context, UA is greater than UB because the utility, that is what we are trying to attribute, the utility in A is greater than the utility in B. Okay, so utility, what is then utility we mean? So utility rankings are ordinal in nature in that sense. So they records the relative desirability of commodity bundles. Because utility measures are non-unique, it makes no sense to consider how much more utility is gained from A than from B. So it is also impossible to compare utility between people. So this is very important, because the people comparison, the people's utility comparison is impossible. This is what is way back in 1930s, the great discussions which was actually took place in the Economic Journal, which was in fact talked about all these things. So we will come to that later. So utility is affected. Another point is that utility is affected by the consumption of a physical commodities, psychological attitudes, peer group pressures, personal experience, and general cultural environment, etc. So one person's utility is basically dependent to that of the other person. So this is a little bit different perspective, because see, normally what we try to see that, you know, in a choice theoretic framework of an earlier origin, it has always been recognized that individual independently decides everything, but your independence is actually dependent on many aspects, such as these things like physical commodity, the consumption of physical commodity, psychological attitude, peer group pressure, personal experience, etc. So these are realistic understanding, though we will see that as in a very different perspective altogether. So then there is another set of issue which is called, the economists generally devote attention to quantifiable options while holding constant the other things that affects utility, which is called the ceteris paribus assumption. So what we are trying to make in this particular thing is that, you know, when I am saying that you have a utility, you keep all other factors influence constant. Okay, so this is what is actually generally against what we said earlier. So your utility basically depends on many aspects, but at the same time you're trying to say all that aspects we cannot actually take in together to understand and evaluate the commodity utility. Then you are trying to make a point that, you know, certain things you have to keep in mind, but at the same time all these are independent, you know, rather than to go for go for saying that it is actually independent. So there are issues with this kind of understanding, but making an assumption in a theoretical setting is not a problem. So you can make any kind of assumptions, but you have to rationalize assumption. And once you have a rationalized assumption, then you see that whether the rationalized assumption follows certain results, and that results has to be consistent, or, you know, it should be unique kind of thing. then and then only you can say that the theoretical formulation which we had, or the formulation which had any sort of a theoretical validity. Otherwise, what we normally call that is a hypothesis or conjecture, which can be changed when the circumstance changes, or within when if your assumptions are consistent but at the same time your results are not, then you say that your theory is absolutely nonsense. So we can have all kinds of discussion in the coming sessions in that sense. So before that, what you have to assume, that is the other characteristic regarding the assumption, is that when you assume that an individual must choose among consumption good x1 to xn, that is the most important thing, because as I said earlier, when I am saying about a choice of an individual or preference of an individual, we are trying to make a point that we are putting the person in a box. All right, okay, you cannot actually speak something out of your box, because the ability, the willingness, everything has to come. So it is basically makes a person limiting to his capacity or her capacity, and making a choice or a preference, right? So I wish to have actually an aeroplane in my backyard, but the problem is that I can't, because if I'm in India, you cannot afford an aeroplane in your backyard. So that's, but if in United States or some other country, maybe probably you can afford. So the issue is that the goods which we talk about is also has to have comes under the bracket of your wish, not only your wish but also you, whether you can execute that. So that is why I'm saying that when I'm speaking about apple or orange or chicken or meat or fish, whatever, so you have to make that is actually available in your set. Anything is other than available outside your set, then it is difficult to make a comparable analysis of that. So that is the first and foremost important assumption which people can make, that is an individual must choose among consumption good x1 to xn. This x1 to xn is actually what is given to you in that sense, or available to you. So this is the most important assumption, very simple assumption by virtue of factors looks like, but it is not. So the second point is the individual's ranking can be showed by a utility function of the form. Okay, that means when I'm saying that something is being expressed, then it has to have its own format. So that format is what is we have. It's in a standard, pretty standard. It's very basic also. So the utility is equal to u x1 to xn. That's it. So keep in mind that everything is being held constant except x1 to xn. That's what we said, that the ceteris paribus assumption is very important. At the same time, you have all this preference changes, because preferences or the utility of the particular commodity is depends on many other factors at the same time. So, but if you keep changing all the influencing factors, then the problem is that never you make a choice which is actually a consistent choice. So we'll discuss that, the consistency problem, when we discuss about the sense paradox, etc. So I'll come to that later in the later half of our lectures. So in that context, this is also a very looks like trivial, but it's not trivial. It's simple. That is everything is being held constant. That is ceteris paribus except x1 to xn relation. So once you make this clear, that is all the three assumption intact, then you can define an economic good in the utility function that the x are assumed to be goods. Okay, so I said x1 to xn is available to you. That means that x1 to xn can be treated as a good. Okay, so different goods are available to you, and if different goods are available to you, then you can say that we can rank accordingly, because we have already seen so that there is a preference ordering, and that is based on your own ranking, and that ranking make certain commodity better and the other commodity worse off. So out of that you can actually arrive at a particular thing. That decision is what is called a choice. So we'll come to that later. So once you have all this is, then in simple, that is now you have a quantity of x and a quantity of y in the two-dimensional vector space. So you just figure out whatever commodity is available in the brackets of x as well as in the brackets of y. So once you keep figuring it out, and then you can say that whether you can actually take a single commodity bundle or the combination of commodity bundle. So you can also decide. That's what we always have a two-dimensional vector space like this. Okay, and now what is you called, this is preferred. Once you have actually this willingness as well as the affordability, as in the very beginning we said that what is the demand. So that itself a separate discussion, which is the next discussion, that is about the budget and all. So I will come to that. But if you have this, provided that you have a budget, an entitlement or an income which is make you to afford this thing, then in fact you have at least has to have a Y-star extra, which is the minimum. Or if you have more money, then you can have affordability of a higher and higher level. So that is what is called the preferred zone. You at least go to the minimum of the Y-star extra, or you will go to the higher and higher order, which is what is called the shaded areas of the commodity, which is preferred to X star X. So this is what is says that when at least people try to start with the X star and Y star, or else if they can have a more affordable means, then they can go a higher order, which is called the preferred zones. So at least I have X star and Y star, else I'll go for a higher X star as well as a higher Y star. So this is what is called the preferred zone. At the same time, you have a portion which is actually, if you can afford, then there are certain point which is called the worse than X star, Y star. So once you say that at least I need X star and Y star, then anything below that X star is suboptimal. So for you, it is not actually as required. Sorry, it is actually underutilization of what you have, or resources. For example, if I want to drink a cup of water, so if I really need a cup of water, so then I must go for it. That's what is called the extra. But at the same time, if I'll get only half of the thing, then it is actually, my thirst may not be actually served properly. Therefore, it is a worse solution. And if I have more thirst, then as well as I can afford more, then I can go for more units of water or glasses of water. So this is what is actually we are trying to reflect. But this preferred zone as well as the worse than zones are there, and between that there is a indifference zone. So this is what is actually simply logically people try to say that there is an indifference zone. So an indifference curve shows a set of consumption bundle among which the individual is indifferent. So what is indifference? This is very important. Okay, so we are trying to delve into the other aspect of the understanding. So I know that most of you are aware of all this fact. So what is an indifference curve? Indifference curve in traditionally, or in simple sense, we define that, okay, locus of point of different combination, which gives the same level of utility. Okay, so look at this particular blue line. That is locus of point of different combination, which is trying to say that the individual gets same level of utility, but not same level of commodity. So the commodity combination is different, but at the same time, the utility is what they accrue is almost same. So you drink a Pepsi Cola or a Coca Cola or a Limca, or it's all after all soda. So some people would say that, okay, let's have a combination. Okay, but still your thirst would be true. Some likes water, some like something else, maza or other. So all this is actually trying to say that the amount in which you are trying to actually consume to reduce your thirst, then that is what is called your utility level. So in that sense, for different combination, though the commodities are different, but you may be having a benchmark, but that benchmark quantity would be different for different products, but at the same time the utility combination which you are talking about is going to be one and the same. This is what is called the indifference of the line which is going to form, but we will have more scientific mechanism of deriving indifference curve in the coming lectures. So this is what is in a nutshell people try to give and reflect upon. So now you have this combination of x1 and x2, or x1 and y1 and x2 y2 provide the same level of utility. And if you observe this graph, so the same is actually can be derived and extendable in different combination of x1 x and a different combination of y in that sense. So now an interesting fact is that this curve is though pointing towards their axis, but we know that actually it never touches. Now once it touches means that at some point you have actually a zero utility of commodity. So zero utility means something, it will go out from the commodity bundle which you're talking, or a preference bundle which we are talking about. So in that sense only people try to say that actually there cannot be any sort of a zero value which is supposed to be there with the commodity. So if that is the case, then before reaching that particular point, the commodity's value be in that sense exhausted, and that is out of the bundle. It will get out of the bundle. So that is, I'll discuss about that again in the subsequent lectures. So now the issue is regarding. See, now you have all this thing, and this is the additional unit, additional utility under this particular graph makes some wondering point, like what is the additional utility if you move from the y1 x1 combination to y2 x2 combination. So in this case, if you are talking about an indifference curve, so the combination, there would be actually it's a very tricky point. Like when the quantity changes, but as I said, the utility never changes. Okay, then only you can say that it is an indifference curve. So the marginal rate of substitution comes at that particular point. Like, and what is the substitution rate at which people have? What is actually we are trying to say is that we are not actually giving any priority to the total. What we are trying to say that what makes a person changing from one commodity to another. There would be a change in the utility of the commodity level, but not at the total level. So this is what is the most important. If there is a change in the total level, then the indifference curve shifts. It will never, remain as in the same position as we think. Then you can't call it as an indifference curve. So then it is shift. That means there is a high utility increase or a decrease. So these are the two kind of interesting point which we have to, because we'll come to that, the formalization and all in a while. So the negative of the slope of the indifference curve at any point is called the marginal rate of substitution, which is called the MRS. That is the rate at which you are trying to sacrifice for the other commodity. So this is what is called the MRS, which is actually an inverse of your change in Y to that of change in X. Okay, where your U is equal to U. That means your total utility, that is the utility which we talk, is going to be remain same. That is why maybe this function is different. That is dy by dx is different, but your total utility has to be the same, otherwise it will shift. So that is why this is normally people never speak, but it is implicit. Okay, unless and until you are very clear about this particular point, things are going to get out of your hand. So marginal rate of substitution changes as x and y changes reflects the individual's willingness to trade y for x. So this is what is actually pointed at this level. And at y x1 and y1, the indifference curve is steeper in that sense. So that means the person would be willing to give up more y to gain additional unit of x. Once it is steeper, then that commodity's preference is actually falling. It will get inelastic. So the utility level also get inelastic in that sense. So you will give up that portion. So you don't actually move towards the extremes. What you try to do is actually you will come to the point at which you have a more possibility of trade. Okay. Similar the case with the x2 y2 case. So the indifference curve is flatter. That means on the contrary, it is steeper for the other commodity. The person would be willing to give up less y to gain additional unit of x. Okay, this is the inverse of the dual of the first case. So now you have an indifference curve. As I said, if your total increases, then your curve shifts. Not it does expand and contract in the same curve. So expansion and contraction is actually try to use the indifference of the points of different combinational commodity. Whereas a shift is actually an increase, an absolute increase in the quantity, the volume in the utility which you gain from the volume of commodity consumed. Now, each point must have an indifference curve through it, and therefore you have U1 to U3. As we all know that actually higher and higher utility curve means higher and higher. So higher and higher level of utility curve imply that a higher utility which is given. So the lower segment of the utility curve, the lower level of utility curve, that is U1, is actually gives you less utility than U3 because more gives you better. So this is what is the logic which we are trying to apply. So this is called an increasing utility path. Okay. So now there is an issue of the transitivity comes at this point. That is why transitivity is important. Can two of the individuals in difference curve intersect? See, transitivity, as I said, it is actually less than 3 commodity combination issue. If it is more than 3 combination, then it is going to be having a cyclical effect. So for understanding this is in a discrete sense, now you have given two bundles. One bundle is having C and B, and the other bundle is having A and C. So now, if you say that when A and C is given, you prefer C, and when B and C is actually given, then you prefer C. That imply that A and B are not given actually. So there is no comparison between A and B. So every time what you contact is actually with C. But suppose if you say that when C and B is available, you prefer B, and C and A is actually being available, then you prefer A, then there is no issue. But in the first case, which I said, then there is going to be a slighter issue. That is, if the three are available, then there is an issue that which one we are going to select. That means if A is given, B is given, and C is given, A is being ranked as greater than B is greater than C, then it must be A which is always greater than C. But sometimes if you say that A is greater than B and B is greater than C, but also when A and C is given, then if C is greater than A, then there is a circularity problem. This is what is actually the intersection try to gives us. Okay, so because the intersection point is actually a point where both A and B same level of utility being actually supplied at C. So that will create a kind of a cyclicity, an intransitivity in the problem. So the individual is indifferent between A and C. The individual also indifferent between B and C. Transitive suggests that the individual should be indifferent between A and B. But you know that that is not actually the case, because for in this kind of a graph, B is falling above A. Okay, so there is an issue, but B is preferred to, because in the earlier assumption what we said, a higher point in the indifference map gives you a better utility. If that is the case, then B should be preferred to A, because B contains more X and Y than A. But that is going to have a problem. Okay, so this is actually violates the transitivity condition. So again, we will come to that point later in a detailed segment when we discuss more about it. For a conceptual level, this is, I think, sufficient. If you have any question, please note it down and ask at the end of the session. So now the second kind of issue is called the convexity problem. as I mentioned in the last lecture also about convexity. A set of point is convex if any two points can be joined by a straight line that is contained completely within the set. So this is what is to understand a simple convexity. That is, anything contains within the 2 points, then you say that particular kind is called that curvature is called convex curvature. Okay, the assumption of the diminishing marginal rate of substitution is equivalent to the assumption that all combination of x and y which are preferred to x star and y star form a convex set. So any point if you take with a straight line, what is a straight line? It is actually a perfect substitute kind. So then you can say that it is actually contained inside. All right. Then you can say that this relationship is having a convex relationship. So if the indifference curve is convex, then the combination x1 plus x2 by 2 and y1 plus y2 by 2 will be preferred to either x1 y1 or x2 y2. So this is what is actually in a nutshell. So your x1 and y1 is in this case um, is less than this x1 plus x2 by 2. That is, averages are preferred over extremes. This is what is in another sense we are trying to make. So y1 plus y2 by 2 or x1 plus x2 by 2 is what we are trying to say the following point, that is averages, which is always been preferred over extremes if it is a convex relationship. So this is what is the point. So what are the extreme points? Y1 and x1 as well as y2 and x2. So y2 and x2 are two extreme points. If you say that y1 and x2 exist at the same time, you are trying to say that there is a convexity assumption is prevailed in the model, then it implies that the averages are going to be preferred over the extremes. That is y1 plus y1 plus y2 divided by 2, which is the first average, and x1 plus x2 by 2 is the second average, which is going to give you better utility, because that point, that the intersection point is actually falls at a higher indifference curve than the other 2 points when you compare. So that is what is called the convexity assumption. So this implies that well-balanced bundles are preferred to bundles that are heavily weighted towards one commodity. Okay. And now, if you have this convexity as well as transitivity assumption, along with the indifference map and marginal rate of substitution is defined, then naturally what you do is actually going to talk about relationship, which is called the function, the working of the utility. All right, the utility function can be immediately derived. How we are going to do? So a preference relation that is complete, reflexive, transitive, and continuous can be represented by a continuous utility function. This is the definition, and as an alternative or as a complement to the indifference map of the previous lecture. So continuity means that small changes to a consumption bundle cause only small change to the preference utility level. I have already pointed out in the last lecture. So again, utility function, that is a utility function Ux represents a preference relation, that is your greater than tilde signs of the greater than sign, if and only if your x0 is strictly preferred to x1, which imply that the utility of x0 is greater than the utility of x1. Sorry. If it is not actually preferred, that is x1 is preferred over x0, that imply that utility of x0 is less than utility of x1. Same, now if it is only a tilde line, that is x0 is indifferent, that is the third one is called the indifference. Now this is the first one. The first notation is called a preference notation, that is strictly preferred. Okay. In the second one is actually strictly not preferred. Okay. and the last one is an indifference. All right. Okay. So what does it mean? It means that the utility which we derive from the x0 is equal to the utility which we derive from x1. So all the three relations are given. All this is called the relations, and we normally represent in textbook R. So with an R, or what you call the first one, the preference relation notation, that is this slightly that particular symbol represents that there is a relation which is also a preference relation as well as an indifference relation. Okay, so we will take up when there is a question comes. So utility function, therefore, in that sense, is in our analysis has always been understood in terms of an ordinal format. That is, utility is an ordinal, that is ordering or ranking concept, rather than one utility, two utility, three utility kind of a cardinal attributes. Okay, so that is called the cardinal utility function, and this is now largely in the choice framework we use the ordinal method or ranking method. You say that I like a person than the other, but you cannot say that how much I like, because that's very subjective. Okay, you like means you like, so there is no numbering attributing like 100 unit of love or 200 unit of likes we can attribute. So what do you say? I like apple because I like it. Okay, something like that. So your ordering is therefore given, but you can't simply say that how much. Okay, you can simply say that comparably I like this over that. Okay, that makes much more sense than saying that 10 units of like of this thing to that of 9 unit of like to the other. Okay, so people maybe seems think that it is actually looks similar, but it is not. So for example, if utility x is actually 6 and utility y u of x u of y is actually 2, then bundle x is strictly preferred to bundle y. It's an arbitrary assumption. However, x is not necessarily 3 times better than y. So normally we say that ux is actually 6 and uy is given 2. It never says that actually in a cardinal sense it is actually 3 times, but in an ordinal sense it is not 3 times. It is simply say that it is better than the other. Okay. Again, considering the bundle 4, 1, 2, 3 as an example and 2, 2. Suppose 2, 3 is greater than 4, 1, which is indifferent to 2, 2. Assigns to these bundles any number that preserves the preference ordering. That is, if you say that 2, 3, which is equal to 6 is greater than 4, 1, which is equal to utility of 2, 2, which is equal to 4. So in that sense, what you are trying to say, you call this number utility levels. Okay, but nothing else is having nothing else comes with as a value for when you rely upon the ordering mechanism. But when you do cardinal assumptions, these are going to have really difficult uh, tool of analysis. Okay, so we will discuss that also when we proceed to higher level of discussions. So an indifference curve contains equally preferred bundle, that is equal preference imply that same utility level. Therefore, all bundles on an indifference curve have the same utility level. This is what is we have discussed in the beginning. Now, so the bundle 4, 1 and 2, 2 are on the indifference curve with utility level 4, which is u, which is identical to 4. But the bundle 2, 3 is on the indifference curve with its utility level is u identical to 6. So that means one can be actually lopsided to the far left, far right, and the other may be actually on the other side. So if that is the case, then what you immediately derives from this particular number, the following mechanism. That is, you have 2, 3. So 2, 3 is you just number it and you form a two-dimensional vector space. Then 2, 3 is actually somewhere there, 2 and 3. 2, 3 means a 2 y, a 2x, 2x2, and 3x1. Okay. At the same time, you can also say that 4x. So the first letter represents the x-axis and the second letter represents the y-axis. Now, if that is the case, in the first case, what you do is actually 2 and 3, that is the blue line. And then you have a pink one, which is 2, 2. Then you have actually a 4, 1. Now 4, 1 is actually this one, that is x1, 4 and 1, x2. So 4, 1 and that is 2, 2 and 4, 1 falls in the same indifference curve. But at the same time, 2, 3 is actually at the higher indifference. In that sense, it is actually belongs to a higher indifference curve, means it is a greater than utility than the other two. So other two are actually falls in the same indifference curve. Therefore, their utility level is actually. So this is the beauty of the analysis. If any doubt comes, we will discuss mathematically. So functional utility function, that is, if first one, that is u is a utility function that represents a preference relation, and the second one, f is the strictly increasing function. Then you have a relationship that is v, which is equal to f of u, is also the utility function representing the original preference function. So in this case, v is equal to 2u. That is what I would like to. So you can have exercises in the intermediary microeconomics. That is, in the wherein you can see different kind of such an example. And this lecture is also from based on variant. Okay. So now we can also move towards the other kind of commodities, like goods which is having a characteristic of good element, bad element, as well as a neutral element. That means you have a preference towards commodity based on its characteristics, that whether the commodity is a neutral commodity or a bad commodity or a good commodity. That's it. So a good is a commodity unit which increases utility, gives a more preferred bundle. In the beginning of our lecture, we started asking this question. The very first lecture, we discussed about this. And a bad is a commodity unit which decreases utility level. It gives a less preferred bundle. A neutral is a commodity unit which does not change utility, gives an equal preferred bundle. Okay. So this is what is actually going to be looks like. So goods, bads, and neutrals. Utility for a unit of water are goods, unit of water are bads. But at some point, it is actually a neutral commodity. Now, based on this, there are different utility functions which is developed. The standard utility functions which we are frequently going to use is the Cobb-Douglas utility function, which is well-behaved utility function as far as the analysis or analytical points are concerned. So that has been notated, or it has been expressed in the form that ux1, x2 is equal to x1 alpha and x2 beta. So this is what is called the Cobb-Douglas utility, where you say that A is greater than 0 as well as B. So you have this two point, that is ratios, which is greater than 0. That means any point which we talk about is of the commodity X or Y, they do have a positive utility. So it will never be 0. So if it is 0, then that commodity get nullified. Then you will have an lopsided indifference, or the indifference touches to the other extreme. So let's go to the perfect substitute utility function. So the perfect substitute utility function is called ux1 x2, where your ax1 plus bx2 is what is called the total utility. So in that case, your alpha and beta is going to give the same kind of understanding. So MRS in this case is actually inverse of A by B, which imply that the perfect substitute case is actually leaves any, it is perfect. That means actually the slope is going to be exact to that of the other commodity. So x gives up for y is exactly equals if y gives the same level of utility which x gives. Otherwise, you will never give up. So this is what is called the perfect substitute. So in that case, you will have a straight line, not a curve. So in the Cobb-Douglas case, you have a curve, okay, where this ratios are actually having a positive thing as well as it is not necessarily equal, okay, but it can be greater than 0 and less than 1. All right, for alpha as well as beta. Beta in that sense is actually 1 minus alpha. So simple. So perfect complementary utility function is this one, that is your ux1 x2 is minimum of x1 and x2. So at least x1 and x2 together consumes, then and then only you will have some utility. So that is what is actually you don't in fact have a MRS in that case. So I think because the marginal rate of substitution between these two is not possible. Why? Because it is together consumed. So there is no substitution between these two commodity. Okay, it has to be consumed together. So you will have only discrete point, as I said in the previous lecture. So you will have discrete point, and that is what has been represented in the Leontief. Say, even if you increase the right hand shoes more pairs, nobody is going to pick unless you supply a left hand shoe. So your utility therefore comes with the complementarity rather than a substitution. So therefore the MRS analysis makes no sense at that particular point. So the preference can be represented by a utility function if the function forms a certain nice properties. Example, when you consider ux1 and x2, which is equal to x1 times x2, then you have a partial difference, that is partial differentiation of utility by partial differentiation of x1 is greater than 0, and you have a partial differentiation of utility by partial differentiation of x2 which is also greater than 0. Then you are saying that actually the commodity which is x and y is having a positive utility. Otherwise you don't say that. Actually, as I pointed earlier, that every commodity has to have a value as well as utility. Otherwise you will never include that commodity inside your bundle. So this is very important and very particular as far as the commodity analysis is concerned. Now, along a particular indifference curve, you also ends up certain point that the constants comes up. X1 times x2 is equal to constant. Then it implies that x2 is equal to c by x1. So if you want to actually move towards x, or if you want to increase x1, then you have to actually reduce x2 in that context. So if it is perfectly, because your income is in this case is constrained. So you have a given entitlement. Out of that, you have to choose either x1 or x2 or combination of both, as I said. Okay, if both has positive utility, then you will choose at least some portion of the x1 or x2. Okay, and you can actually increase the amount of x1 or x2 by reducing the other. So this is what is characterizes a downward sloping indifference curve in that sense. Interestingly, can be derived from a schedule, okay, utility schedule. This is also given in different textbooks. When it comes to the Cobb-Douglas case, I have already mentioned about it. and you can follow. So a Cobb-Douglas indifference curve is always looks like this, so convex indifference curve, and which is having a well-behaved, which is always treated as a well-behaved. All curves are hyperbolic, asymptotic too, but never touches any axis. As I said, the alpha and beta is actually greater than zero. Therefore, it never touches to the x-axis or y-axis or the commodity axis. Now, perfect substitute case also I have mentioned. Now, this is what is a curve of a perfect substitutes looks like, a straight line. Okay. Now, the lower and lower the straight line means lower level of utility. Higher level of perfect substitute utility curve gives you higher level of. All are linear and parallel. Okay. Now, complementary case, as I said, there is no basically substitute. Why? Because only at that point of the 45-degree, which is in fact determines the level of commodity consumption optimal. Because any other point, it makes no sense for the same level of utility. Even you keep increasing, no changes is going to happen. So there is no, in fact, substitutability here. Okay, because it is complementary opposite of. So one point, and if you want to increase the utility, just move to the next point, not in the same, because the same never gives you anything. Okay, all are right angled with the vertical vertices or corners on a ray from the origin. So this is, in fact, in my view, it is called the dotted preference. Okay, in a 45-degree line. Okay, now when it comes to the marginal means incremental utility, the marginal utility of a product I is the ratio or a rate of change of the utility as the quantity of product I consumed changes by 1 unit. That is MUI is equal to dou U by dou XI. So this is what is the very simplest understanding of the marginal utility. Now you can keep understanding with the two elements in the set there where you have an mu which is equal to the total change in utility divided by the total change of x. So this is what was called the delta. Gives you delta utility which is equal to mu x times the change in delta x. The marginal utility which you will get from the second commodity is also derived in the same fashion with the reverse thing. That is, you were change delta u by delta x2 implies that the change in utility, that is delta u, which is equal to mu2 times change in x2 along a particular, because this is actually keep the other things constant. That is why it is called ceteris paribus assumption. When I speak about x1 commodity, I'll make the x2 commodity constant. So that is why it is called a partial derivation. Okay, along a particular indifference curve, you have this particular format. Okay, so your marginal utility and other things. So this is the kind you can see in the textbook. Okay, so if you have any doubt, we will discuss it. Yeah. Because in the online lecture, if I keep telling all this thing, then you will get more confusion. So you just work it out. Okay, so if you want to really test that whether the marginal utility changes over different number, which if you attributes, like the example which I said in the beginning, you can simply derive this conclusion of this kind. Now, another concept which we need to understand in this case is the monotonic transformation and the marginal rate of substitution. That is, applying a monotonic transformation to a utility function representing a preference relation simply creates another utility function representing the same preference relation. So the question is, what happens to the marginal rate of substitution when a monotonic transformation is applied? This is what is the result also, hopefully nothing. Okay, so the monotonic transformation is trying to say that actually the direction in which it is moving. Okay, monotonic transformation, it's actually saying that the same direction it is moves. Okay, if that is the case, the change of MRS is exactly in the same direction the utility changes. Okay. Again, this is also you have to work it out with your example, because if I'll tell you without a class, physical class, it is difficult. Okay. It's in fact very simple. Most of you might have studied, so I don't want to complicate it. Okay. Also there. Yeah. Now let me have the relationship of all this thing. Yeah, this is mentioned. Yeah. I think one last point in this particular analysis called the lexicographic function again in the utility. So what is a lexicographic preference? A is preferred to B if there are two conditions, like first one, x1a which is greater than x1b, or in the second case, x1a is equal to x1b, but x2a is greater than x2b. Okay. A is inferior to B. A is inferior to B. From the point, dotted point in the two-dimensional vector space, it is clear that you have x1 on the x-axis and x2 on the y-axis. Okay. Now you see the assumption that one first and second one. So if A is inferior to B, that is x1 health and yx2 money. So people say that money is having more value. Okay, for a terminally ill patient and than X1. Certain things people try to say that they don't actually fall in a combination type of thing. So you have a strict preference over certain commodity. Like some people prefer health. Okay, some people prefer money. So, for a terminal ill patient, health is better because to achieve health they need money. So they prefer money. Why they prefer money? To have a good health, because they are terminally ill. So people have also different kinds of logic like this to deal with their problem, which is their encounters in their day-to-day life. So more practical things will be followed in the next set of understanding. Now this lecture is trying to give you a snapshot only to see that what is actually the concepts which we are going to deal with in the furtherance of understanding the microeconomic behavior uh, and the consumption pattern in that sense, or consumers preference pattern in that sense. So now I'm actually asking all of you to read this book, Intermediary Microeconomics, especially the portion of utility, which will give you a kind of understanding. And after that, we will have a discussion in the next lecture. Just before the beginning of the next lecture, we will have a discussion. So then we'll proceed to the next lecture. Okay. So with this, let me conclude today's lecture because this is I think a little bit heavy, and thanks for listening, and I hope that this lecture is useful to all of you.